Hey guys, in this video I'm going to explain through an example how to find limiting reactant, percent yield and excess reactant. Without any further ado, let's dive into it. Let's take a look at this example. What is the maximum amount of calcium phosphate that can be prepared from 12.9 gram of calcium hydroxide and 18.37 gram of phosphoric acid? First we have to write and balance the chemical equation. In this case it's already written unbalanced. After we have to find the number of moles for each reactant. So let's find the number of moles. In order to find the limiting reactant, we have to divide this number of moles with a corresponding coefficient in the balanced equation. Who has the smallest ratio is the limiting reactant. And from the compound that is limiting reactant, we are going to run the calculation to calculate the theoretical yield of the reactions. So, from here we see that the ratio for the calcium hydroxide is smaller than the ratio for phosphoric acid, which means that this one is the limiting reactant. If you are wondering for these numbers, 3 and 2 are the ones that are the coefficients in the balanced equations. So this is the compound that we are going to use to run the calculation to find the theoretical yield. This is a scheme to use the conversion factors. Keep in mind that this step here is the stoichiometrical step. I mean, the step that we have to play with the balanced equation. And I started from the number of moles because we already found the number of moles for the calcium hydroxide that we have it here. So let's find the mass that we are going to produce by this limiting reactant. So from here we find that the maximum amount that we can produce with a given amount of the reactants is 18 gram. This is the theoretical yield. What if the exercise asks you to find the percent yield by giving you that the actual yield for calcium phosphate is 15 gram? So, in order to find the percent yield, we are going to use the theoretical yield that we calculated above, this one here, and the actual yield that is given here, this one. So from here we find that the percent yield is 83.33%. The last point that I want to mention on this topic is the excess reactant, which is the one where some of it remains as a reactant after the limiting reactant is consumed completely. So let's find for the example above how many grams of phosphoric acid is in excess. Phosphoric acid is considered excess reactant because we have more than we need to react stoichiometrically with calcium hydroxide. Firstly, we have to find how many grams do we need to react in stoichiometrical way with the limiting reactant, which in our case is calcium hydroxide. After we find this, we can find with difference the amount that is in excess for phosphoric acid. So let's rewrite the equation and run again the calculation. This time we are going to start from the mass of the limiting reactant and move further. So from this scheme, this step here is the stoichiometrical step. We are going to take into account the coefficients in the balanced equation. So let's run the calculation. This amount here is the one that is going to be consumed, or the amount needed to react stoichiometrically with the calcium hydroxide. But we have 18.37 gram. From this amount, we are going to remove the amount that is going to be consumed and to leave only the amount that remains in the solution or in the reaction or in the reactor unreacted, untouched. This is the excess that is not going to react, because we do not have more from the other compound to react. It is limited by the limiting reactant. That's why it has the name limiting reactant. That's it for this video, guys. If you find it helpful, give it a thumbs up. Thanks for watching, see you in the next video, peace.